right, cool. So we got this thing up and working. Let me just download the file so I can start sharing with you, and then we'll get this party started. Let's see. So here's my question. While I'm downloading this file, I want to ask you, if I asked you what is to find the average of something, can you tell me how to do that? Yeah, I'm asking you a question. If I asked you to find the average of something, what would you say? Add them all together and divide by the amount of numbers there are. Good. It's the mean. Yes, exactly. All right. I'm glad you added that clarifying statement. That you're exactly right. It's the mean. That's the mean. But there are three different kinds of averages. Technically, before you tell me, hey, add them all together and divide by the amount of numbers there are, what you should ask me if I told you, hey, find the average of something, what you really should say is, okay, well, which one? Which average do you want me to find? Do you want me to find the mean, the median, or the mode? You know what I mean? So let me kind of share with you what the difference of those are and why we would have them. Got it? So what I did was I made a little table, and we'll call this table, I made a little chart, and this chart is the average or the annual salary of geography majors. So if you're thinking about going to college and say that you look up, hey, I'm going to go to college and I'm going to major in geography. Got it? And so what I did was I found, let's see, how many is this? It's 18. So I was found about 15 different salaries of geography majors for maybe, let's say, for the year 2000. Got it? 15 years ago. So if we want to find the mean, then like you said, Caitlin, what you would do is you add them all together. Okay? And you would find the, you would add them all together and you would divide by the numbers you added. How many are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, so there's 15 numbers. So you would add all of those numbers together and you would divide by 15. And I basically can tell the computer to do it really quickly by basically putting the formula equals average and then just grabbing all that data right there. Close parentheses, bada bing, bada boom. Are we cool with that? Does that make sense? Yes, it does. No, it doesn't. In fact, the word, you know how, like I told you, when I ask you for the average, it's so common that you just add them all up together and divide by that same number that it's so common that in order to put it into the computer, all you got to do is type in average, and it doesn't ask you, well, which average do you want, the mean, median, or mode. I guess it assumes that you want the mean. If you want to find the median of a number, well, if you don't have the spreadsheet, what you would do is you would organize that number from smallest to biggest, and then you would basically put it in as the, or you would organize it from smallest to biggest, and then what you would do is you would find the number that's in the middle, right? And so one way that I can do that on the spreadsheet is I just press equals median, bada bing, bada boom, I'm done. We cool? All right. So I have a question. What is if you're majoring in geography, say that you go to college, you major in geography, you're going into the job market, you're expecting to get a job. What do you think is a better picture of your salary, of your starting pay would be? The mean or the median, or it doesn't make a difference? It's about the same. This is just your best guess. Hello? You guys alive? IDK. Actually, to be honest with you, I guess it is kind of a trick question. It doesn't matter. It's either the mean or the median. Not necessarily that it doesn't matter. It's just they're so close to each other that you can't really tell the difference. All right, I'm going to add one more salary from the year 2000. Actually, specifically from the year 1998, and it was. A person that I really enjoyed. I know of him as a geography major. Can I add his salary in there so that way we can get a better picture of this thing? In 1998, there was a geography major that I know, and he made 33. He did quite well for himself. He made $33 million for himself. Oh wait! I know what I need to do. Sorry. All right. So he made $33 million for himself. Would you guys like to know who this person was? I mean, as a geography major, you're making $33 million. That's pretty good, right? Well, I'll tell you. And I don't know, if you guys are into basketball, you might know who this is. This guy's name is Michael Jordan. Michael Jordan was a geography major in college. And yes, he probably wasn't making $33 million that particular year between 1997 and 1998 or doing geography. He was making $33 million that year playing basketball. But technically, he should go inside of this in this list because he is a geography major. And I told you, this is a made-up list of annual income for geography majors. Now let's look at what the mean is. The mean goes from, I want it to be the average. See, it's only collecting data from here to here. I want it to include 19 as well, so I'm going to change that there. All right, so the mean is $2,113,000, $128.06. Look at what the median did. Look at how that changed. All right, I'm going to go and delete that thing. All right, look at the numbers now, and then I'm going to add in the 33 million again. Okay? Now imagine this, okay? In 1998, 1997, you're looking at the average salary for, for geography majors, and you look at this and you say, dude, when I get out of college, the average salary of geography majors for the year 1997 is $2,133,128 a year. That is like 20 times what doctors make when they graduate. And it's just a 4-year degree, so then you go into majoring in geography, right? Right? But is $2 million a year starting salary reasonable? Like, is that really a good picture of how much you'll make? I'll tell you now, you'll be sorely disappointed. I mean, it's not to say I have anything against geography majors. I'm sure they make more money. They may maybe make more money than me. They probably do. But $2 million a year? And you see, that technically is the mean, right? I added up all these numbers. I divided by 16 this time because I have 16 numbers to deal with. Look what happened. That number just got all kinds of crazy happened to it. Now, what happened to the median? Before the median was this, 54,000. Now the median is 55,000. So all it did was it shifted the median over one slot. Here, let me do this. I'm going to sort this from A to Z. Okay. So the median used to be here, and all the median did now was shifted over to around here. Actually, technically, it's the middle number between here and here. So you've got this crazy outlier, that's what we kind of call it, on the outside, because Michael Jordan was a geography major, and I should include him in this list. But he's like way, way, way off the scale. You know what I mean? And the mean couldn't really handle that. The mean couldn't really adjust for that. Because the mean basically, is the middle number between all of these numbers. Whereas the median, that did a lot better as far as staying consistent. Does that make sense? At the very worst, it just moved it up to the next level. But it didn't really go that far away from from what you should expect. So, in this case, which is a better picture, which the mean or the median in this case, is a better picture of what you will reasonably be making as a geography major when you go into the workforce? The median. Yes, and it's almost obvious. If you are thinking that you're going to get out of college and make $2 million, you are quite disillusioned. $2 million a year as a geography major. Now, you might be a geography major and then invent the cure for cancer, and then you might be making $2 million a year. Hey, if you invent the cure for cancer, I'm sure you're going to be making much more than Michael Jordan did. Maybe, I don't know. But, you know what I mean? If you're going and majoring in geography and then landing a job as a geographer or whatever it is geography majors do with their degrees, then reasonably I would say you won't be making $2 million a year. You know what I mean? So, in this case, the mean is actually worthless to us. The median is actually the one that is of only any good use to us. So now I can justify, well, that's why we have medians. Then the next question is, well, why do we have modes? The modes is the number that comes up the most often. And my answer to that is, in statistics, it has similar properties as the median. There are different reasons, there are different scenarios, and I can't think of a good story off the top of my head as to why you would want to use the mode instead of the median. But I guess maybe that would make sense. You want to find out the thing that comes up the most often. Which number comes up the most often. Huh. Maybe yeah, I can think of a scenario where you would want to use the mode. Say like when you're throwing dice and you want to find which number the dice land on the most often. So anyway, do you guys kind of see a bit, or at least have I motivated you to understand the difference between median and mode, and why we would have three of them, and why we would even want to learn them in the first place? Hello? Yes, no? All right, cool. All right, so let's go to chapter 2. All right, let's see. I want to skip the warm up. I'm kind of bored with the box and whisker stuff. Computing the mean data. All right, let's see. What are they asking us to do? All right, fine. The mean data set. Find the average. Find the mean of this data. Okay. Well, let's see. All I got to do is plug in that data into my computer. So 496, 498. Oops. 498, 505. 510, 512, 517, 525, 547, 560, 570, 585, 590, 600. And then I want to find let's ask, what is the median? Shoot, I can just do this. Oops. Never mind. It's not dollars. I don't want it in dollars. Format. Number. All right. So the median of that thing is 525. What is the mean? Well, what we're going to do is, like you said, we're going to add up all the data values and divide by the total number of data values. So in this case, we're going to add them all up. And so if you want to find the mean, or actually it doesn't use the word mean, it uses the average. You basically just take all these numbers, add them all up, divide that by how much? Divide that by how many? 13. And then your answer is 539.62. Cool. All right. This is really important, so I want you guys to take a look at this. So the symbols that we use when we want to find the average is we use a line that goes right above the letter. So this is saying the average value of x. That's what we use when we want to write the math. Can you guys see that all right? All right. Now, this right here might look a little bit scary to you, and let me just kind of unscarify it. This right here, that crazy looking E symbol, that's a Greek letter capital sigma, S-I-G-M-A. And in math, we call it a summation. Now, when you hear the word summation, when I ask you to sum something, what does that mean to you? What are you thinking in your head when you hear summation? Hello? When you hear the word summation, what is that kind of telling you that you want to do? You want to add them, exactly. And that's what it is. When you see that summation symbol, it means add. You notice how there's a little x with a little I on the bottom. Did I ever explain to you guys subscripts? Because I wanna unfreak you out when it comes to, you know what that is? Okay, all right, good. So what this is it's basically saying this piece of data is, we'll call this x sub 1, and then this piece of data we'll call x sub 2, x sub 3, and so on and so forth. I think I can just get the computer to. Yeah, all right. And then so what they're saying is, I want you to add x1, and then x2, x3, x4. You use this small I as kind of a counter, and it goes through all of the different numbers. So it goes from 1 to whatever number you want to end at. So I want you to add x1 and x2 and x3 and x4 and x5 and x6. And then I want you to divide it by n. And n is the total number of whatever numbers you're using. Are we cool? Hey, do me a favor. I'm going to share this link with you guys. It's the same exact spreadsheet that we used last time. I want you guys to go to this spreadsheet. Let's work together on this stuff, okay? Oops. Try this link. I think the first one I messed up. Don't click on that one. That's not going to take you anywhere. Tell me when you guys are in. Awesome. Go to the bottom sheet where it says like sheet 9 or something like that. It's on the bottom tabs over here. All right, cool. Here's what I want you to do. I want you to just practice a few Savannah, click on this cell that I have over here, right here. Can you guys click there? All right. Savannah, I want you to start putting in these numbers, 2, 5, 4, 6, 8, blah, blah, blah. Kaylin, put in these numbers into your thing. Because I want you guys to show me that you guys know how to take the average of something. You can't see it on the table. What do you mean you can't see it on the table? Huh. It doesn't have it. If I share with you this link, you click there, it will take you there. But what, does it not say that you can actually edit it? Does it say up here somewhere, like view only? Alright. Well, I hope that you guys understand how to take the average, I guess. I wanted to see if you guys could do that for me. Alright, cool. Let's do this one then. Ready? So let's talk about this one over here. Now, what was this data showing? This is the... Oh, okay, word counts for an English paper. Alright. So apparently... Alright, don't worry about it. Just review, or just refer back to what, you know, what my screen is sharing with you. I have no idea why it's not sharing with you correctly. Alright, anyway. Apparently these are the word counts for an English paper that's, you know, kids have submitted. So the average word count is, or the median is 525 words, and then the mean is 540 words, 539.62 words. And then say that, you know, Mr. Dalday comes by. Mr. Dalday isn't a great writer, so he writes a paper with 50 words. Wait, is this average working correctly? Oh, I see. Yeah. Exactly, there we go. On the bottom of the screen, there's sheet 9. Click on sheet 9, that's where I'm at. I get it. You guys probably went to here first, huh? You guys are like, why did you send me to that sheet? No, on the bottom there's sheet 9. That's where I'm at. All right, cool. Anyway, we'll move on. So, let's see. Here's the mean. Here's the median. If you increase the largest data value, will you change the median? That's my question. If you make, instead of doing 600, you make it 700, will you change the median? Will the median look any different? Be any different? Yes or no? Yes, no, IDK. Everyone has to answer. All 2 of you. Yes. No, actually. Like, look, the median is right here, 525. Right? Kaylin, click on 525 for me. Okay, good. Hold your mouse there. That's the median right there. Now, if I make this number bigger, that still keeps that number over here in the middle. Does that make sense? Look, actually, you can just see. Look, your median is 525. If I made that 700, someone wrote a book, not an English paper. Look, the median is still 525. Now, does the mean change? Does your average change? Yes, the average will change because you're adding a different number and you're dividing it, but the median won't change. So, if you, okay, so basically, which is a better measurement, which measures the central tendency, or which measure of central tendency is more sensitive to large or small variations? Which one will change more if I change, like if I make some small changes on the outsides? The mean or the median? Yeah. Actually, the mean will change more if I change the numbers on the outside. The median kind of holds itself nice and firm. So again, they're kind of going over, well, here's the advantages of medians versus means. Does that make sense? All right. Let's see. If we throw in a 0 into the data set, will the mean remain unchanged? No, the mean will change if you throw in a 0. If I take this and I plug in a 0 over here, actually I'm going to bring that back to 600. The mean will totally change. It'll go to 501. Because even though I'm adding 0 to the top, I'm dividing by another number. Instead of dividing by, 13, I'll divide by 14. Does that make sense? All right. Now, what I need to cover with you is this is actually really important. And I feel like this one you'll definitely see in your in advanced science classes. So in your physics class, in your chemistry class, you're going to see this. And so and especially when you hit college. So pay particular attention to this lesson that I'm going to teach you right now, and it's talking about standard deviation, and it basically talks about like the kind of spread away from where like what something is, the spread of the data, okay, how much it deviates from the middle. So here's what we're going to do. Let's take this data over here. Let me just delete my stuff over here. All right, so this is the mean, this is the median. Okay, let's find out more data. Let's add all right, so what other pieces of information can we get? All right, we can get the lower quartile. And the lower quartile is, I'll just say equals, how do I do it? Yeah, equals quartile, and then I would do these data right here, and then I would say 1. All right, so this is the lower quartile, is 510. First lower quartile. Why did they not get the same one that I did? 570. Let's see. If this is the mean, or the median, then I want to find the... Oh. They're calculating it wrong. Alright, here's what you do. Alright, this is the median. This is all from last time, right? Here's the median. The lower quartile is the median of these numbers. But since there's 6 numbers, the middle of these numbers is between 505 and 510. So what you want to do is for the lower quartile, that's the median of this. And then this is the median of the top half, which is this. Are we cool? So the middle of the data is here. A quarter of the way there is, let's see, insert. Do me a favor, Savannah, put your cursor right here. Just so I have place markers. All right, cool. And then, Kaylin, put your cursor right over there. All right, cool. And then I'm going to add one slot below here. All right. So basically, I'm breaking up the data into three parts or 4 parts. Here's halfway, which is where Kaylin's at. Here's a quarter of the way, and here's 3/4 of the way. So here's the question I have: is like, what percentage of the data is above 525? Well, exactly half of it, 50%. And what's below? Exactly 50%. The first quartile is where Kaylin's at, or Savannah's at. And what percentage is below this number? How much of your data is below of it? 25%. And how much is above? %75%. Yeah, exactly. Cool. There we go. And then same question over here is how much is below? Well, below this number over here where I'm at, that would be 75% of the numbers are below, my upper quartile, and 25% are above my upper quartile. Are we cool with that? Now I need you to introduce to you the concept of the spread of a number. And this one is actually, let's see. This one is, I'll go through the equation with you very slowly. What we're going to do is we're going to measure how far a number, a piece of data will deviate from, from the middle, from the middle. And what we're going to do is we're going to add it all up and see how that works. Are we cool? So let me delete this. I'll show you what to do. Okay? So here's the equation we're going to use is sigma equals the big square root of the summation sign of this symbol right here, the x with the line over it we talked about. That's the average, as in the mean, minus x1, and then divided by, or square that, and then divide that by n. By the way, just to let you know, why do you think I square it and then square root it? Did you notice that? Why do you think I square something and then square root it? Well, I'll tell you why. If you think about it, that's kind of a sneaky way of finding the absolute value of something, right? Like, it will take all your numbers and make them a positive number. Because, like, what's negative 4 squared? Is positive 16, right? And then square root that. Okay, well, that's positive 4. So, essentially, it's kind of like a way of doing an absolute value. It's making sure that all of my values are positive. Anyway, let me build this table for you and show you how I would find the thing. Here's the data itself. And then, let's see. What I want to do is I want to find, well, what is the average? I'm talking about the mean. Well, the average is just equals this number. Equals $V, $1. All right, that's the average. Are we cool with that? All right, so now what I want to do is I want to find how far does each number deviate away from the mean. How far away does it deviate? So what I mean by deviate is when I want to find how far something is, I would just say, okay, well, that's equal to this number minus that number. So apparently this number is 43 words away from the average, the exact mean of something. So this would be x minus x sub I. And then so that's for this x, x1. And then if I want to find the next one, I would just basically do the same thing. And so this table right here shows me how the difference. I'm just subtracting this number minus that number. Are we cool? Now what I'm going to do is square it. So I'll just call this difference. That was finding the difference. This is the square of difference. So I'm just going to say, okay, I want to take this number, I want to square it. So you get some big number. But notice what those numbers are as well. Notice that they're all positive. Okay? So this gives me this part so far. I've got the average, I've got each thing, and I'm squaring it. Then what I want to do is I want to add them all up. So I want to add them all up, and I want to divide by the number of things that I'm adding. Okay, that's basically just finding the average. So let's see. What is the sum of these numbers right here? It's some big number like 16,000. And then I'm going to say, okay, this is the sum of the numbers. And then here's the average, because I'll just take this number and divide it by 13. So I get 1,295, right? But that's squared what I want. So what I'm going to do is I'm going to square root it. So that's equal to the square root of the above number, 35.99. Are we cool? All right. What this tells me is it tells me that it basically kind of gives me a standard way of talking about how spread out these numbers are. Okay? If my numbers are really close together, like let's say this is 500, and then this is 596. Actually, let's make them even closer. Let's make this 540, and this will be 540. I'll throw in a few more of those. All right. Look, I changed up the numbers a little bit. The mean kind of stayed the same as before. But the difference is, notice what happened to the standard deviation. The standard deviation got smaller. So what this is telling me is the spread of the numbers. How spread out they are. These numbers aren't as spread out as before. Does that make sense? I guess maybe it might actually help if I did a graph of this thing. See if I can make a little graph. Let's see, format, insert, chart. Okay, yeah, let's do this. We'll do a little histogram. All right, so check this out. So here's a little histogram of my numbers. Got it? And it's a histogram because I'm grouping it in groups of 20. So as I change this data, let's see. What if I made this thing like 700, and then I'll make this one like 300. 540 minus 540. Oh, let's make this 400. Do you see how what happens is my mean stayed the same. The middle of all of these numbers stayed the same. But the data is a lot more spread out. So notice what happened to the standard deviation. It got up to 65.93. So what it's saying is my data is really far spread out from each other. You know what I mean? All right. Here. I'll tell you. I can think of a really good example. Okay. Anyone ever play art? Anyone ever do archery? Have you ever done archery? Yes, you've shot archery. Okay. Now, let's say that you're shooting an archery target, and obviously the goal is to get to the middle of the bullseye each time. That's what you want to do. You want to hit the middle, right? But I think almost as important as trying to shoot where you want to, almost just as important, you want to shoot them really close to each other, right? Like, I guess we call that the spread. You don't want your target. If you shoot 10 arrows, you don't want all 10 arrows to be like. I guess I would much rather have. Let's see. I would much rather have my archery session look like this, okay, than this. You know what I mean? See, like this all the arrows are all spread all over the place. Now, if I were to average, so like I take a tape measure and I measure the distance from the center to where each arrow lies, okay? And then I find the mean of this. And then say like over here, this is the positive side and here's the negative side. So if if I measure over here, it will be a positive distance. If I measure over here, it will be a negative distance. I basically want to find where exactly the average is. And say that since the arrows are spread out.
Sorry, you're going to need to come because you never sent me an update too.
Yeah, I'll be there. I'll be there. I'm just finishing. Say that I want to center this thing. I mean, say that when I find the mean, I find the average of them, it lands right in the middle over here. And I'd be like, dude, my mean is like 1 centimeter from the bullseye. You know, and you would think, wow, Mr. Dalton is a really good archery person. But the thing is, my standard deviation, the spread of all of my data is really high. Right? So that makes me kind of a crappy archery person. Whereas if you have this scenario where, you know, your average is going to be in the middle, but not only that, your standard deviation is really small. The data doesn't deviate very much. Then that's actually that means I'm really good at archery. Because what this tells me is if I'm looking at this, I can say, well, that person not only shoots the right target, but that person can pull out an arrow and almost every shot will go in the same spot. You know what I mean? It will be the group will be clustered really close together. So actually, I don't necessarily. What I want is accuracy and consistency. Now, the mean will measure my accuracy. It will measure how accurate I can get. The standard deviation, that measures my consistency. It measures, you know, how spread out my arrows are versus how clustered together they are. So this number, this standard deviation that we're looking at, is a measurement of how clustered your data is. If it's spread out pretty far like that, then your standard deviation is really high. Whereas if you're 539, let's look at this data over here. Whereas now my cluster is really close together like this, and then look, my standard deviation is really small. It's not 65, it's 29, because my data is closer together. In fact, if I just go 539, 539, and I make all of this 539, look, the mean stayed the same. And the standard deviation in this case is 0, because it means that like all of the data is so clustered, it's stacked all on top of each other. How much does this, you know, how big of a spread does this thing have? Well, not very much. Or like, let's make this one 540, and then we'll make this one 538. Look, the mean is still the same. It's 539. But in this case, I have a small standard deviation because I do have a little bit of a spread going on there. Does that make sense to you? So the way you apply this, the way you're going to use this, and this is actually going to be, this is why I'm telling you about this, is the way you're going to use this is you're going to basically, if you use this, if you do a bunch of experiments and you take a bunch of data, and then what you want to do is you want to say, okay, well, this is the average thing I got, but here's the standard deviation because this is how, you know, close these things are. This is how close my measurements were. This is the, you know, how far each thing deviated. And I guess the ideal would be to get your standard deviation as small as possible. But this is just a mathematical way of measuring how far spread out your data is. All right. If we're cool with that, then I've taught you standard deviation. That's a pretty important lesson when it comes to statistics. I don't know if you'll see it on an EOC exam. You might. I don't know. But you'll definitely see it in chemistry or physics or whatever. And so that's kind of my lesson of that. I have to get to another meeting, and then I got to come back upstairs. Today's a crazy day. I will talk to you later.